Yo, yo. Got the scope out to do some dope scope shit. But more importantly, trying to get these servo drives in torque mode for the little belt tensioner over there. And to do that, that drive needs a 0 to 10 volt analog signal. But in order to produce that from a 5 volt microcontroller, you gotta have some type of pulse width modulation that comes out of the microcontroller into this analog digital conversion board that receives 12 volt power. That way it has enough headroom to take the pulse width modulation that's coming out of pin 9 into this thing and then produce a swallowing swath of changing voltage based on what kind of code you feed it. The Arduino likes to see 0 to 256 as the range of available resolution of different pulse widths that would vary voltage. So if I'm here and I've got this Arduino set up in serial mode on Windows to receive a serial stream from this Python code, and by running this we're going to loop through 0 to 256, write each byte each time. We'll print it to the screen just for sanity, and then sleep a little bit of time, 5 milliseconds, until we go from 0 all the way up to max, and then drop it back down to 0 and close the connection. When you hit play here, we'll see that the voltage, which right now is 400 millivolts, would go up to about 10 and then come right on back to 0 to prove that this is going to work. So there you go. So we're starting to move. We're at 2, 3, 4. So that's taking the serial input, which could be modified by iRacing, into the Arduino for pulse width modulation to the conversion board to get a readout analog 0 to 10, which is going to represent 0 to 100% on what the drive should do for the torque range at the motor. So now that this is working, and that's working, the code to produce this through iRacing is separate shit, but that won't be that bad. All we got to do now is connect these pins to the right pins on the drive, and that motor over there should be turning. Later.